All right, I want to talk about friction. Friction is a special kind of force, and the stuff you already know about forces, Newton's laws, is going to apply to this, but there's some specific things that we need to talk about with friction. You already know that friction is the force that opposes motion. I don't have to tell you that. And this friction is fun is not just a funny joke. It's not just to get you to try to like physics. It's a way to get you to remember the formula for calculating friction. And that's this. The force of friction equals, this is the Greek letter mu, mu, times the normal force. Okay, forces and friction, force of friction and normal force, you know what those are. We've talked about forces before. That's probably familiar to you. But this mu may not be. Mu is called the coefficient of friction. And the coefficient of friction is just a number that simply describes how much friction a surface has, how much a particular surface will oppose the motion of something else rubbing against it. The coefficient of friction is unitless, and it's also always positive. Okay, and for that reason, with this equation, and I'll frequently call this the fun equation, we will not ever enter any negatives into this equation, which is important to remember because many times on the free body diagrams that we draw in here for friction, you have gravity, you have normal force, and you have something over here, probably applied force, and then it's fighting against the force of friction. And a lot of times we draw friction going to the left, which means it's negative. And even though friction is negative for sigma F equals ma, it's negative for a free body diagram. Don't worry about putting the negative into this equation because we're just concerned about magnitude here. Reason is because the coefficient of friction needs to be positive. Now, the truth is, if you do put a negative in here, it's not really going to affect very much. It won't change the number since there's no addition and subtraction here. It just may make it negative instead of positive. So you can just take off the negative if that happens. If you do a Google search for these two things, coefficient of friction for rubber and the coefficient of friction for wood, you may find a lot of different things, but hopefully for rubber you'll find something between 0.8 to, I don't know, 1.17, 1.2, something like that. This should be a 0. So we'll just call it 0.85. And the mu for wood, we can call this 0.6. Okay, remember these are the numbers, these are unitless. In this class at least, mu will usually be between 0 and 1. Usually. In the real world it's not. It's actually possible to have coefficient of friction that's greater than 1 in some cases. And that's pretty significant because here's what mu means. Really all this is a percentage. And what this says is that the force of friction on some sort of rubber is 85%, so that's the mu. The force of friction is 85% of whatever the normal force is of the object that is sitting on it. Okay, and if you're talking about wood, the force of friction on wood is 60% of the normal force of the object that's sitting on it. Okay, and that's why it's pretty significant to think about mu being greater than 1, because that means, and mu can even be up to like 4 or 5 sometimes. Okay, most of the time, and in this class that's not the case, but that can be, and that means that the frictional force on that surface can be 4 to 5 times whatever the normal force is of the thing that's sitting on it. But in this class, 0 to 1 is going to be the norm. So just looking at this equation, there are two things that directly affect the force of friction, and that's the coefficient of friction, mu, and the normal force. So these are directly related to the force of friction. In other words, if the normal force increases, the force of friction increases. And if the coefficient of friction increases, the force of friction also increases as well. How do you increase the coefficient of friction? Well, the only way to do that, coefficient of friction is specific for every type of surface. So for instance, if you're driving a car, the only way to change your coefficient of friction is to move to a different surface, like get off of the ice and get onto the road type thing, you know. The way to increase the normal force, if we look at our free body diagram, at least to begin with in this class, the gravitational force is always going to be equal to the normal force, and that's what this says right here. Normal force is usually the same as an object's weight, and the weight is the same thing as the force of gravity. Those are the same thing. The way to increase the normal force is to increase the force of gravity, to increase the weight. So those of you, some of you may drive a pickup truck, okay? And if you haven't ever driven one before, maybe you will in the future, or you can just picture this. If you drive a pickup truck, you definitely want to drive a pickup truck in a dry condition versus a wet condition. The reason being, when it's raining, there's a lot less friction on the road. And if you do that, it's really easy to start fishtailing in a truck or even spin out at a stop sign. And if you think about a truck, and I can hopefully try to draw one here. If you think about the front wheels versus the back wheels of the truck, there's a much greater gravitational force and thus normal force over the front wheels than there is in the back. And that's because the engine is up here. It's a really heavy thing. It's weighing the front wheels down more than the back wheels. You have much more of a normal force here. You have much more contact with the road, much better contact with the road. And these are the wheels that usually cause the drive force in a truck. And so it spins out really easily in a pickup truck because there's not much weight in the back end. And that's the reason why people will throw old tires or bricks or something in the back in order to increase the normal force on the back side of the truck where the drive is occurring. So increasing the normal force increases the force of friction back there. You want as much friction as you can between your tires and your car. Again, the normal force is usually the same as the force of gravity or the weight, except if you're on a hill or a ramp or an inclined plane. There's some physics involved there that involve trigonometry, and we're really not going to discuss that in this class particularly. We are going to discuss the second situation, however, which is pulling something or pushing down on the object even though it's on a flat surface. And a good example of that is like mowing the lawn, right? If you have a lawnmower, you don't push straight forward on the mower, you're actually pushing down on the handle. When you push down at an angle, there's a component of your force that goes this way in the x direction, and there's a component of your force that goes down, which means you are actually pushing down on the lawnmower, which means the ground that the mower is sitting on must apply a greater normal force to keep the mower from falling through the ground. In other words, the normal force is even greater than it would be if you weren't pushing on the mower, because you're pushing down at an angle. But you don't have to worry about that. We're going to talk about that in a later set of notes. Just know that in that case, the normal force is not equal to the force of gravity. But for these set of notes, it will be, because your free body diagram is going to look like this initially. In this class, we discussed two types of friction, but there are really three. So I'm going to tell you about a third one. The first type of friction is the one that you need to overcome to set an object in motion. It's resting, you're going to get it in motion, and that means you have to overcome a force called the static friction. Static friction is what you have to overcome to set an object in motion if it's at rest. And the force needed to overcome to keep an object in motion, if it's already in motion, you are fighting kinetic friction. Kinetic friction is sometimes also called sliding friction. And it's important that you know both terms, because kinetic friction means, or kinetic friction is only in place when two objects are literally sliding past each other. Okay, that's the only time that you actually get kinetic friction. So right here is where I usually talk about an anti-lock brake system. Right? Let's consider that. If you think about your car, all cars today are made with anti-lock brake systems, right? Anti-lock brakes. If you're moving this way, the purpose of an anti-lock brake system is it kind of pumps your brakes back and forth. It'll put them on and pull them off, put them on, put them back off. The purpose of an anti-lock brake system is anti-lock, right? You do not want your wheels to lock when you are braking. And the reason why is if your wheels lock, you will begin to slide on the surface that you're on. Okay? And here's the reason why you don't want to slide. And hopefully you remember this from the lab that we did the other day when we pulled the wood blocks across the table. Static friction is actually quite a bit higher than kinetic friction is. Static friction is higher than kinetic friction. So the question is, when you're driving in a normal circumstance, do you have static or kinetic friction between your tires and the road? A lot of students want to say that you have kinetic friction between your tires and your road because they reason that the car is moving. But that's not the case. You don't have kinetic friction in a normal circumstance because the tires, hopefully, are not sliding across the road. In a normal circumstance, you have another type of friction occurring that's called rolling friction. Okay, rolling friction is actually really, really similar to static friction because if you think about it, when this surface of the wheel comes in contact with the ground, right? So the wheel comes down and it contacts the ground. While it's in contact with the ground, the wheel does not slide back and forth on the ground at all, or at least not significantly. Comes in contact with the ground for that brief instant, and then it comes back up again, having never slid on the ground. So as long as we don't have any sliding going on, there's no kinetic friction. And it's not really the same thing as static friction either, because you can't say they're still. That's when we get rolling friction, and it's really similar to static friction. It's still very high. So as long as we can stay in our cars, as long as we can stay in the rolling friction range, we'll be okay. And that's the purpose of the anti-lock brake system. Anti-lock brakes allow you to come to a stop without getting your tires skidding or sliding across the road. If your tires begin to slide, then you have entered into kinetic friction. And all of a sudden, the friction force between your tires and the road decreases dramatically, which means if you are sliding, it will take much longer to stop than it will if you stay in the rolling friction range. So that's a good example of static and kinetic friction, and it's probably familiar to you because I think you probably heard it in your driver's ed class.